Hey, I'm Christina Warren here with Channel 9. We are at the University of Washington at UW Dubhacks 2017. 600 hackers joined us this weekend for a 24-hour hackathon in all kinds of different technologies. Microsoft's a sponsor, Blue Origin's a sponsor, Google, lots of companies here. But let's go inside and talk to some of the hackers and see what's going on.
My name is Doremi, and I am director this year. Thank you so much for coming out to Seattle on a wonderful rainy day. We wouldn't have it any other way.
All right, so now I'm here with Lingle, and they're going to tell us what they worked on and what technologies they used.
Sure. So we made an app so that when you learn a new language, you can just walk around the room, point it at the objects you like, and tell us what you think the translation is, and it's going to tell you if you were right. And if you were wrong, it would tell you what the right translation was. And this way you would learn like kids do. So it's called See and Say. It's a very powerful way to learn a new language. That's why kids are so good at new languages.
Cool, so it's kind of like walking flashcards, but it's automatically translating stuff for you.
Yeah, and you eliminate another language in between. So you learn the objects right away.
Awesome. So what technologies did you use to build this?
So we used Microsoft Bing Speech API. We also used Google Translation API and Google Vision API.
And the Google Vision API. So what languages did you use this for, kind of for your test?
Yeah, so it's just JavaScript. So it's pure front end. So it's just HTML, CSS, JavaScript, and nothing else.
Very cool. This is awesome. Lingo.
Yeah, thank you very much.
Thank you. All right, we're here right now with Doremi, who's going to tell us a little bit about their project and what problem they were trying to solve. So lay it out for me, guys.
Right, so we are Doremi, and we created an app that classifies a user's environments by taking in a bunch of factors and playing music that is generally matches the vibe of your surroundings. So we take in information through like a camera, and we measure characteristics about the environment as well as weather data and geolocation of a user to be able to play music. For example,
so for instance, if you're like walking through a forest, we wanted to play something that was kind of more tranquil, just kind of match the vibe of the forest.
So some Bon Iver or something like that.
Yeah, exactly. And then, so the reason we did this was because we wanted the music to like tell a story of where you are, and music is like a international, like universal thing. So we wanted kind of a way for people across the world to be able to to feel what an experience would like sound like.
So you're kind of building like the perfect playlist for like any situation.
Yeah. I sort of imagine it as like I'm a superhero, I'm walking through my day, and this is my soundtrack. So that's kind of the vibe we were going for.
Okay, I love that. So you're kind of walking through the day, and like basically your soundtrack is whatever's happening around you.
Exactly, yeah.
Very cool. Thanks, guys.
Yeah, thank you.
Hi, we're Transvid. So imagine you want to watch a YouTube video in foreign language, and imagine you're blind. So YouTube does a great job in translating and subtitling languages, but for those who never learned how to read or those who have visual disability, we wanted them to actually hear what they're saying.
Yeah. And now we're enabling the Chrome extension to English.
Giggling. Hello. Q as you want. Coffee groaning. Coffee groaning. Croissant. Coffee.
This is so cool. So tell me a little bit about the technology you used to accomplish this.
So in terms of getting YouTube content and information, we use Google API, and then we got the information, and then we use Microsoft's speech and translate APIs to like actually translate and be able to like speak. Yeah, so we use mostly Google API and Microsoft.
And Microsoft APIs. And you built this as a Chrome extension. What type of latency did you have? Because it seemed like it was pretty real time. So, like, what are you doing as far as, are you kind of like looking at the transcript of the YouTube videos ahead and then translating that? Like, what are you guys doing?
Yeah, so we actually wanted to do it real time, but we realized that it's kind of hard right now as far as like So we actually grabbed the transcript by using Google API, and then we translated.
And then you sent that to the Microsoft services stuff to translate over. That's so cool.
Yeah.
That's so cool. That's a great solution to make it as real time as possible. That's really cool.
Yeah.
So Transmit. Awesome work. Great job, guys.
Yeah.
Thank you.
All right, we're here with a very cool project. Tell me what are your names and tell me about what you hacked on.
My name is Joy.
My name is Jenny.
Okay.
And we worked on Identify.
Identify. All right, so tell me about Identify, because I saw the demo a couple minutes ago. It's super cool. What's the problem you're trying to solve, and how are you solving it?
So basically the problem we're trying to solve is people with low vision loss. And our problem came with Jenny. Jenny's sister teaches piano, and one of her students struggles with looking at the sight reading, the sheet music, because he can't see properly. And that really impedes his learning experience. Over the world, there are over 250 million people who have some sort of vision loss, and we really want to tackle that problem with our product, Identify.
So basically what Identify does is it detects text images in the video and it enlarges them. If I have that, it detects the text and it basically zooms in on the text and also has an overlay of black and white so that if it's like some kind of like shade that colorblind people can't read, then they can read the black and white font.
So what technologies did you guys use to build Identify?
So we used a web base because we wanted to be accessible both on the web browser as well as the mobile phones. And then the language we use is JavaScript, as well as we use Polymer. Anything else you want to add?
We use Microsoft's Cognitive Systems API, specifically OCR, to do the actual bounding box and text detection on the images so that we can get that kind of information and display it.
Awesome. Thanks so much, guys.
Thank you.
What's your name and tell me about your project?
My name is Jesse, and this is called Cloud VR.
Cloud VR. Okay.
Myself.
And I'm Gabe.
Gabe and Jesse. Okay.
Yep. We spent the entire weekend working on this idea as it's supposed to be a technology that's used to replace like modern day meetings and things like that.
Okay.
Not just that, but also make the digital realm more physical.
Okay.
So what we made was an actual in Unity a room that can be maintained and moved and things like that using the Alexa voice command. So when you're wearing the VR headset, you can tell Alexa to move something. And in the game, the things will move as well as you see the screen.
So it'll move around in your virtual space.
Mm-hmm. Yep.
Okay, cool.
As well as you'll be able to see other people in your virtual space. That part isn't added yet. That's something that we hope
You're hoping to add
yeah.
in the future. Okay.
So with AWS, we have a RESTful API server running, and the Alexa skill that we developed. So the Alexa skill, we can ask it to move things around, and it will update the data accordingly.
Very cool.
Thank you.
Awesome. Great work, guys. All right, we're here with Alert, and they're going to show off what they've been working on and talk about the problem they're trying to solve.
Hi, yeah, so we're from Alert, and our system is a crowdsourcing app coupled with a smart backpack that's aiming to increase personal safety within kind of campus communities. And so the motivation for this project is, as students, we often have to walk home, and we're walking home alone and at night. And there's reason to feel unsafe. I have pepper spray in one hand, I have my phone in the other. I text my roommate like, hey, I'm coming home in half an hour, look out for me. If you don't see me, like, check up. I'm checking over my shoulder and seeing, is there anyone behind me in the shadows?
And she's not just being paranoid.
Yeah.
Even last week, we got an alert from UW Alerts that told us that a girl had been sexually assaulted on campus going into her own dorm room. But this was sent out 2 hours after the fact, when this is something that I would have liked to know.
Yeah. And like our friend is, sometimes things don't get reported to the police. Like if you're walking down the street and some guys are catcalling you, it's probably not going to be something that you report to the police, but you would want to know about as a fellow student.
So that's where our crowdsourcing comes in.
Yeah.
The yellow pins on the map here are events that people can drop. So they can walk through, they can get catcalled by guys, and they can go on their app and say, I was uncomfortable here, I felt unsafe here, and other viewers can see it.
So it's kind of like ways for, I've got a mic, so it's kind of like ways, but like letting know like what's happening around you.
Kind of. It also has the Seattle PD updates, and that obviously since they're updating, they can see the information themselves and review, hey, a lot of people felt unsafe in this one neighborhood. Why don't we increase our presence there? Why don't we put a new light in?
Yeah.
So it really works as a sustainable environment too.
Awesome. Yeah.
And you get all of these features in-app, but it also works with the back.
Yeah, so all these features that we just talked about are sustainable if you just have the app on its own, but it also couples with a smart backpack. So one of the things we talked about earlier is that at night, it's kind of hard to tell who's behind you in the shadows. And so this smart backpack has a sensor on the back such that if Kate's walking home and I'm kind of behind her, this light goes off. And it's not a physical defense against anyone, but it tells her like, hey, I should look behind me and be more aware of my surroundings. And the lastly is that similar to how a house with a visible security system and like signs that say we're protected by so-and-so security company make someone less likely to like rob the house. If I'm behind Kate, sensor goes off, she turns around and I'm still coming at her, she sets off this alarm. Everyone in the area turns and looks at her, and maybe as an attacker, I don't want to.
You don't want to mess with that.
No,
right?
not at all.
I'm protected.
So how did you guys build this? What technologies did you use?
Yeah. Can we actually bring our developers in? Because they did a lot of the work, and I want them to get the credit too.
Dev
so,
team,
come on.
you're cute.
Jack,
Hi.
Kevin, all right.
Yeah, so we built this, it's a native Android app, some Google Maps integration for visualizing these pins. An Arduino is in the backpack to, be connecting with the phone, to, send off a phone call, a text, stuff like that. Yes, SQL Server to, holds all the data that people are posting.
A community member was using the app and they saw something that made them feel unsafe, or they saw like an actual incident occur. They could just drop a pin on the app and then give a text,
As simple as like
a message, say, or like it's really dark here and I really felt unsafe when I was walking by, and so you could report it, and then it pins it on the server, and then she can see it on the server there.
So the police aren't going to tell me that if there's a group of guys that are going to catcall me when I'm walking home, but my fellow college students are. And they're going to let me know when something feels particularly unsafe. And ideally this would have a feature that would clear it after a certain number of days, depending on the level of, severity of the incident, which is still in development. But it gives you a better real-time idea of what you're going to run into when you're walking home.
This is great. I remember when I was in college, like I would have killed for something like this. So this is really great work. Thank you. Good job, guys. Thanks.
Hey everybody, I am here coming to you live from Dubhacks, the University of Washington hackathon, where there are literally hundreds of students gathered around just a hack-on project. It's really exciting. Every year we do this. We come and help them, we mentor them, help them to figure out what project they're going to make, what technology they're going to use, and it's just great to see the energy in the room and to hear the ideas that the students have. We're talking to some of them about employment and their hackathon ideas and just having a really great time.